So this is kind of where we are in terms of the remaining lectures. So there are 4 more lectures, which I always think of in terms of dealing with some of the core mechanisms that we've talked about, so recognizing others, empathy, and so on, and kind of fitting them into specific topics such as how we make decisions about how we interact with each other, relationships, our identity, moral judgments, and so on. So a lot of what I've talked about, kind of the foundational mechanisms that support all this other stuff. So today's lecture is really about, well, I call it interacting with others, but it's about this idea of cooperation, and when we don't cooperate, when we choose not to cooperate or even compete with others, how do we go about doing that, and what kind of mechanisms support that? So cooperation can often be seen as a puzzle when you think about it in terms of a kind of a simple genetic point of view. Because basically, in order to cooperate, cooperation always comes at some cost. Minimally your time, but it might involve other resources, sharing food and so on. This is costly. So how can cooperating actually be of benefit to you as an individual? It seems like a kind of a risky strategy to give up your resources, whether it be your time, your help, or whatever, on other people. Surely you're then increasing the chances of their gene survival rather than yours. And surely the advantageous solution is to receive cooperation rather than give it necessarily. So how does cooperation come about? And of course, not everybody does cooperate. Humans do to a greater or lesser extent, but certainly other species get by without cooperation. So there are some kind of ecological niches in which people don't cooperate. They just come together to mate and then they live solitary lives. So it is a viable solution not to do this. But humans and a lot of other species have chosen a different path for whatever reason. And of course, part of the answer to this is really thinking about cooperation more in terms of putting aside short-term interests in terms of longer-term gain. So it might well be that me kind of helping you now might be costly, but actually the benefits may exceed the costs, at least over some other time frame. So again, the kind of cognitive mechanism that would support that is an ability to kind of have delayed gratification and put aside kind of rewards for the future. And it's not all about immediacy in terms of kind of costs and benefits. It's about being able to have a longer game. And really, the word that we kind of use here is around trust. That this is basically it. So we can kind of unpack what that might mean in terms of neuroscience or cognitive mechanisms and so on. But basically, it's a sense that good deeds will come back to you and that favours will be returned. And of course, that trust can be betrayed, but it's a sense of having that as a belief. Now, where this belief comes from, whether it's socially constructed and so on, we can also kind of think about. But obviously you can trust people either because of some previous history and reputation. So trust might be built up on actually having a memory of, oh yes, I remember you were nice to that person, so therefore you'll be nice to me or whatever. So you build up this kind of thing, and this is obviously like a memory process in which you kind of observe other people's behaviour and figure out who to trust, who you're going to give to. Well, I'll give to them because they're likely to give back. But also there are other social norms for exchange and enforcement. So for exchange it means, that in effect we govern either, via law or just via our kind of consensus, how we behave with one another. So things like religion and so on, that would kind of enshrine certain norms that we all get used to and adhere to. But also there are norms for not cooperating. If you don't pay your taxes, you're mean to people, you don't play the game. There are rules to bring you back in, okay? And also, this is kind of linking back to other kinds of lectures, is that maybe we cooperate and we trust because there are kind of basic needs around kind of reward-based processing. So an intrinsic bias for fairness and kindness. So again, this speaks to mechanisms to do with empathy, mind reading and so on that we've dealt with there, that this would underpin some forms of trust. So trust is one of those ideas that we'll come to throughout the lecture, but obviously there's no trust region of the brain. It's something that is kind of constructed out of other elements. So really we've got two parts of the lecture. The first part is about altruism. So altruism is often seen as kind of being selfless helping. So donating to charity would be a good example of that. Helping somebody who's fallen in the street where you're helping them, but there isn't an immediate or obvious benefit to you. And we'll talk about this both in terms of an evolutionary perspective. How can altruism kind of emerge at a population level trait? And how is it underpinned within individual minds and brains? And then we'll talk about game theory and social decision making. So game theory is about how you make optimal decisions based on your knowledge and other people's knowledge, basically. So it's a branch of mathematics, but it's applied in evolutionary theory and psychology and so on. And we can look at that there. But basically it's rules about what you should do given somebody else's dispositions or somebody else's possible courses of action. And how that kind of enters into the decision as to who to trust and who to cooperate with. So in terms of basic kind of stimulus response processing, we can think of altruism, the stimulus being someone in need or some event that needs help as the response. So one of the definitions of altruism kind of often pulls in this idea of it being a selfless act. So it entails no personal reward to the helper, but comes at some cost. So minimally time and effort, but possibly putting oneself in danger. Now, this whole notion of selfless is really hard to pin down in terms of what that means. And in fact, I think it's highly debatable to what extent altruism is a purely selfless act. Obviously, we get some benefits from helping others that aren't material benefits, but they're kind of more psychological, emotional benefits and so on that might be relatively well hardwired in the brain, but nevertheless a little bit flexible as well. So I'll start off with a kind of an evolutionary perspective of altruism. And here, this is kind of the basic problem that I'd put before, in that how is it possible to improve the survival chances or the fitness, so that the chances of your genes being passed on, of altruists, people who are nice, kind people, given that helping others necessarily entails a personal cost? How can this kind of emerge in a population? And there are various kinds of mechanisms that have been proposed. And again, some might apply to some species and some to others, and so on. So kin selection is one of the first theories to kind of explain how altruism can kind of emerge in evolutionary. And basically, the key kind of insight into kin selection is that basically it's not about survival of you as an individual, it's about survival of your traits and your genes and so on. And basically this is one of the key things in Richard Dawkins' kind of book, The Selfish Gene, that we talk about survival of the fittest, but it's not the survival of the fittest individual, it's survival of beneficial traits which are underpinned by certain genetic variants, okay? And Richard Dawkins was effectively basing his kind of book on this kind of theorizing and so on. So it's nothing to do with being selfish, it's rather about not thinking about yourself as individuals, but in terms of replicating. And of course, people don't think like that. Our brains are wired differently, but the biological mechanisms are kind of driving that sort of behavior. And the logic kind of goes something like this, is that basically, if you help your kin, then you're increasing the chances of your genes surviving. So that's how, in effect, you can create that idea of helping others being of benefit to you, but it's not a benefit to you personally necessarily, it's a benefit to your genes and your trait. And that's the kind of the key disconnect from thinking about this psychologically as opposed to thinking about it from an evolutionary biological perspective. And of course, if you are somebody who helps and is kind, then there's a good chance that your children will be help and kind, partly because they're sharing the same environment, but also because they're sharing the same genes. So those genes will kind of propagate. So in effect, you're creating a kind of survival channels down those people who are helping, whereas families who kind of abandon their children and so on are not going to thrive in the same way. Of course, here there are various kind of ways of mathematically modelling this, but the costs, the benefits of helping your kin depends on who your kin are. So your second cousins and so on, you don't get many benefits because you don't share as many genes with them. So it depends. One of the predictions is that there should be kind of a radiation in terms of who you help, in terms of how many genes you share. And obviously, again, this isn't a psychological mechanism. People don't entertain these thoughts, but that's a kind of more biological underpinning. And again, there is some evidence of this in humans, in terms of who you donate organs to and so on. You're more likely to do it to, your mother, father, brother, sister, and then your kind of cousins, and then so on. It's almost like this web of connectedness, but you're not actually calculating, who's the proportion of genes that are related to you. But that's the basic idea. And again, there are other species who seem to do this. So squirrels sharing their nuts, vampire bats seems to come up quite a lot in this literature. But again, the idea that they help kin more than others. The kind of mechanism you need here is a way of detecting who's kin and who's not. That would be a kind of a precursor of this, kind of cognitively. So the idea there is that by helping, your genes are passed along, and it increases the chances of their genes being passed along as well. So reciprocal altruism. So this is kind of exemplified by this metaphor. Can somebody tell me what this picture here is? Yeah, that's right. What is it? I'll scratch your back if you scratch mine. That's basically it. So this is the idea behind reciprocal altruism, or it's also called direct reciprocity. And of course, it doesn't happen like this in the sense that there's typically a delay, that you're helping somebody now on the basis of a future kind of exchange. So this can be trust, although it can happen directly, and this is basically, the principle of trade and exchange and so on, that you're willing to kind of engage in this sort of trade-off between something that I've got a surplus of and something you've got a surplus of, and kind of exchanging. So you've got something I need, I've got something you need, and you swap it over. So it can be within the same time. So again, here, and this mechanism can obviously apply to strangers as well. All you need is a way of recognizing individuals and memorizing their behavior. That's the kind of basic cognitive mechanism that you would need to do this. And again, you see this in vampire bats game, but also various primates engage in this. So chimpanzees have a way of keeping track of who's donated food to them, and then they return the favor, but they kind of keep ways of doing that. So this is one solution, but this kind of poses a bit of a risk, because again, the optimal solution for an individual in terms of their own in the here and now sort of thing is to accept other people's favors, but not to return them, okay? To just keep everything for yourself. So what are the mechanisms that guard against that? So obviously we'll talk about them later in terms of reputation and so on, that this all kind of matters. But the basic problem here is called freeloading or free riding, is that in many cases this is the optimal solution, at least when you try and model it mathematically, and this is why game theory and this kind of maths comes in, is that the maths tells you accept everything and give nothing, but of course that's not how it works in the real world. And one of the ways that this was looked at is using this kind of mathematical approach to evolution that was put forward by Axelrod and Hamilton, which is basically a way of kind of modeling this kind of reciprocity and figuring out how you can get this to occur in a population of agents, and what prevents freeloading from kind of winning with this. So it's one of these kind of classic papers. If you look at the number of citations, it's kind of in the high thousands, maybe tens of thousands. It's one of those kind of very influential papers that's affected kind of economics, biology, you name it. But it's not straightforward to explain, so let me give it a go. But basically what they have here is what's called a population of agents. So all these are just people, but what they are mathematically is obviously just particular points within this kind of network or particular kind of solutions. And what you have happening is that people are kind of programmed in this kind of simulation to behave in a certain way. So you might have some people who always cooperate, some people who always freeload, and some people who perhaps have some other strategy. Okay? And then what happens is that they engage in some kind of interactions with each other. So if you've got somebody who always helps interacting with somebody who always freeloads, then basically the freeloader gets some points and the helper's points go down. Okay? What then happens is that you kind of breed these agents. So those who've got the highest kind of score, those who've got the most help, or the ones who did the best out of this, are more likely to pass it along. So that is, they got more food, they got more, when they fell down, somebody picked them up, whatever. So that's how they try and do this. But the way it works is something like this. So this is the kind of situation that I talked about. So each person kind of has a rule either to cooperate or not cooperate, which carries this term defect often in this literature. And what happens here is that in this case, this person said, I'm going to cooperate, but this person does not help back. They're a freeloader, at least in this particular exchange. So what happens is that this person here benefits and this person goes down. So that's a plus score. That's a minus score. The actual particular details here don't quite matter, but some details do matter. Okay? So the outcome here is that B has benefits at A's expense. And if B carries on doing this, they will then carry on passing their genes in the next generation. But the problem then is that cooperation will die out. Okay? So let's have a look at a different kind of interaction. So here you've got two cooperators, okay? And what you find here is that both people kind of benefit from cooperation. So this, although there are some costs, this person goes down. But notice here that the number there, so the key thing is the relative difference in number. So receiving cooperation without giving it gives you a higher score than mutual cooperation, okay? So that is important. And the reason being is that you've got something without giving anything back, okay? So here, both people benefit. Okay. Right, what happens if both people don't help each other? Then basically the scores either stay the same or they go up a little bit. But the key thing here is that the number is less than there, because basically the idea is that by cooperating with each other, both scores go up a little bit, but by not cooperating, the scores don't go up as much as through mutual cooperation. So one of the key things about this is how you weight the relative options. But the idea is that mutual cooperation always does better than mutual, I'm going my own way, and that makes sense logically. But receiving cooperation without giving it is, for that individual, the best thing of all. So the numbers don't matter, but the actual ranking of the options does matter. Okay? So what do they find in this kind of mathematical simulation? What you find is that basically, if you have a group of people who always give help and always cooperate, and a group of people who always freeload, then freeloading always wins after so many generations. And this will happen even if you start the model with, say, 5% of people who freeload and 95% of people who cooperate. After so many generations, the freeloaders will spread their genes more than the others, and cooperation will die within that. Okay? So this is kind of puzzling. So how can you change this? So what they actually did is that they asked people to submit kind of rules here for how you might play this game, in effect. So what you might have, for instance, is somebody who plays randomly. So sometimes they cooperate, sometimes they don't. Or you might have is somebody who cooperates, and then as soon as somebody cheats on them, it's like a blanket, I'm never helping you again. So you've got some kind of selectivity in terms of deciding who you cooperate with and who you don't. And as soon as you do this, you can have cooperation being a stable solution, but it's selective cooperation, okay? That you choose who you are cooperating with. If you don't do that, then you're a sap, and basically you're lying yourself open to exploitation. That's the thing. So they did a whole selection of kind of algorithms, and the one that comes out is something called tit for tat. What tit for tat is a simple rule, and what it says is that you always choose to cooperate in the first instance. So it's kind of a nice thing. You start with a positive disposition that I'm going to help you. If somebody doesn't help you back, then you return that. So then in one round, you don't return the favour. But then as soon as somebody reverses their behaviour and starts being nice to you, then you're nice back. So all you're doing is you're just mirroring the other person's behaviour, but starting with the assumption of that person is going to treat you fairly. And this works a lot better than algorithms that are very harsh and really kind of punishing and so on. So this kind of assumes that people are going to be nice, it retaliates when they're not, and it forgives them when they're nice again. So it's kind of almost a rule for living, but it comes out mathematically in these sorts of simulations. And if you do this, basically what you will find is that cooperation can kind of survive no matter how many freeloaders you've got in there, and that cooperation will not be bred out of this kind of network by people just being exploitative. Okay. So it's kind of an interesting thing because it's effectively a mathematical model, but it says something about the kind of way that we should work, maybe. And some religions kind of enshrine this, but they've not done it using computer simulations or whatever. It's kind of just been learnt through intuition and so on. But it also suggests that, there is a slight element of not meanness, but you don't always want to be nice. And if you are, that can be a problem, or it's a risk for you to be too nice, in effect. And that's also something that comes out interestingly. Any kind of questions about that? Because it is a slightly difficult kind of idea. Okay. So the other mechanisms here are sexual selection and indirect reciprocity. So sexual selection is basically a reputation-based effect. And that's the idea that basically being generous is attractive. So people who help others or are generous with their wealth or their time and so on, this is an attractive trait. So basically people will choose to mate with that person, even though there is a cost to it. So the analogy here is the peacock's tail here, which peahens love. They go mad for it. So the bigger the peacock's tail, the more they want to mate with it. But the peacock's tail serves no real purpose other than to attract a mate. And in fact, it comes at a cost to the bird. It's handicapping for it because it has to carry this ridiculous thing around with it all the time. So although it's handicapping to it, the benefits outweigh the cost. And the benefits are, it's like, hey, come and mate with me, and it wins, okay? Obviously, if it gets too big, it can't flee predators and so on. So obviously there are other pressures acting on it as well. But that's the basic idea here, is that the costs and benefits lie with the altruist. So this is a reputation-based process here that you can see in animals and obviously maybe in humans as well. So indirect reciprocity is another notion. So here, this is direct reciprocity. So A helps B and B helps A. So I'll scratch my butt, you scratch yours. There are other mechanisms that are kind of more reputation-based. So this one here would be around this. So Novak and Sigmund argue that this might be something that is more kind of uniquely human due to language and other sorts of mechanisms. But the idea here is that A helps B, and then A gets a reputation of being a good helper, so A then receives help from another person. So here you've got a network of helpers helping other helpers, but how do you know who's a helper? It's kind of by their reputation. So here it's not that B is returning the favour is coming via another person, okay? And again, they've done some mathematical simulations along the lines of kind of Axelrod and Hamilton that suggest you can get this as being a stable strategy in people who aren't going to meet each other, provided that their fitness score is kind of advertisable, provided that they can it's clear to other people in the model what their previous behaviour is. And if you know that, then you can kind of the cooperation will survive rather than be bred out and just leaving everybody looking after themselves and freeloading. Okay. This is another form of indirect reciprocity, which is often kind of thought of as being misguided reciprocity, where A helps B, and then B goes and helps somebody else. So helping after being helped. So the idea here is that I go and help you because you're in a problem, and then you see somebody else in need, so you're more likely to go and help them, having been helped by me. So this So it's not clear what the mechanism behind this is. It's either a kind of a goodwill feeling or some confusion as to who it was that actually helped them, or whatever. But you do see this. So if somebody, you can do it experimentally, that if you help somebody, that person is then more likely to help somebody else down the chain, in effect. So you've got this kind of a chaining effect. So these are mechanisms that can happen in strangers in which you never interact again, okay? Provided you know something about that person, either their reputation or whatever. Well, this is reputation based here. This is just passing it along the chain. Okay. So these are kind of the mechanisms I've talked about aren't kind of neuroscientific mechanisms or really psychological mechanisms. All it is what is the optimal strategy for a group of individuals to kind of cooperate or not cooperate, in effect. So how this is kind of implemented in minds and brains is an open question. So the fact that some insects and so on engage in altruism, and vampire bats do as well, it doesn't mean that it's the same mechanism in vampire bats as in humans and insects. It just means that by evolutionary pressures have just created the same outcomes in different species, because at the end of the day there are benefits from cooperation no matter what the mechanism is in your nervous system that's supporting it. So what I would want to say is that we wouldn't want to conclude that that bats or bees or other species that seem to help each other want or like helping others, even though we're tempted to draw that conclusion in humans, okay? Because it feels like there's something like a free will to choose to help, which you may or may not want to give to lower animals. But nevertheless, they are kind of engaging in something instinctive, but it's not clear what the mental states are that support that in their head. But nor is it the case that in humans that we kind of think that we're making a free will and conscious decisions about who to help, when and where. But actually a lot of these biases might be quite implicit and unconscious. So this is a curious example. We can debate whether it's likely to be conscious or not, but all this is that you go into a psychology common room and one of the people goes and buys milk for the department, puts it in the fridge, and there's a little money box in which people just drop 10p in or 50p whenever they feel like it, just so the pot of money is there. So it's an anonymous donation. But what they have is that on the pot of money, in 1 week they have an image of flowers, and in the other week they have images of eyes looking at them, just on the thing. And again, what you find is that in eye weeks, the monetary donations, the pounds paid per litre of milk consumed is the scale here, just goes up. So again, people aren't dumb. They know that this is a 2D image. They know they're not there. Whether or not people are actually consciously changing their behaviour as a result of this is hard to say, but there is something going on, certainly a subtle bias. So again, if you're doing, shaking of tins for charity and so on, eyes on the thing, or, well, here it's more about enforcement. It's like you're being watched to give or whatever. But again, it's something that maybe is a subtle, perhaps kind of implicit effect. And again, here, this is something that is probably fairly unconscious. So this is one of these imitation studies in which you're doing some kind of interaction, let's build this tower together or whatever, and you just, somebody scratches their head, you scratch your head, so you're just mirroring certain kinds of body language. So people who've been mirrored in this way donate more to charity at the end of this, okay? So and people don't know why they can't justify why they're giving more, okay? So I think that we want to be a little bit careful in saying that the mechanism in humans are all kind of conscious and free will and so on. I think that we are, although we clearly have a sense of that there's something that may be driving us that we can't quite pin down for some of this. And of course, one of the key mechanisms that's been put to lie behind altruism is empathy. And basically, that's the idea that we help others because we care about their welfare. And we care about their welfare because of the effects that they have on us in terms of, positive emotions, kind of feeling good about it, guilt, and so on. That would be one idea. So it's basically a positive disposition or a tendency to kind of empathize with others. But again, here, we don't help others in order to spread our genes, although ultimately that might be the thing that got this kind of system started. Nobody really thinks like the evolutionary biologists like this. It doesn't mean that kind of modelling is incorrect. It just means that the mechanisms that have been created in our minds are not all about spreading our genes. It's more about welfare. But by doing that, we do increase the chances of good behaviour kind of surviving within the population. So this is an old kind of social psychological model of empathy and altruism by Pliavin. And basically the claim here is that when you've got some kind of emergency, you, the perceiver, experiences a physiological response in order to seeing somebody else in distress. So somebody's fallen over, they've got knocked down, they're having a fight or whatever, but you have a physiological response to it in the way that we've already talked about in these kind of lectures in empathy. So that kind of is part of what it is to be empathic, is to have that kind of response. But then there are other kinds of motives here. So in effect, this is something of a kind of cost-benefit analysis that you do. So again here, are you going to help or not doesn't just depend on your empathy, it depends on what are the costs to you. So if you're really busy, maybe you're not going to help. But actually, if somebody's really in distress, then you probably will, okay? So it's a question of what the cost of not helping might be, is somebody going to die? So the cost of not helping being high is giving aid to an injured child or an elderly person who slept on the ice. You're probably going to do that even if you're fairly busy. You're probably going to stop and help. But the cost of helping would be high, for instance, if you see somebody in a knife attack or whatever there. So you've got a cost of helping and a cost of not helping, in effect. And obviously what you're trying to do is that you're more likely to help when the cost of not helping is high and the cost of helping is low. In effect, yeah, I've got time to do it. There's no big repercussions for me. Okay. So it's a mixed kind of mechanism. The empathy is the driving force, but at the end of the day, there is this kind of free will, kind of rational cost-benefit analysis that's kind of tied to it as well. Okay. So instinct plus reason would be one way of thinking about it. The thing about this here is that it's very much tied to personal distress, which is seen as being a selfish motive rather than a selfless motive. So the basic idea is that what you're trying to do is to effectively alleviate your own personal distress as a result of seeing somebody else injured. That you're kind of, although you're doing this cost-benefit analysis, you're actually doing it partly to as a way of kind of mitigating that. So this is seen as being a more selfish rather than a selfless motive. Others have kind of taken an empathy altruism model, but have argued that actually it's not about alleviating your own distress. So this is the work of Batson et al., again from a social psychology perspective. What they do, or what the standard kind of experimental paradigm is here, is that you get people to read a scenario such as, for instance, somebody down the corridor is being evicted, and then you're given a rating scale, how likely are you to help the person in this context, and so on. Then you're asked afterwards about your own feelings in the scenario. And what you find is that this thing called empathic concern, which is kind of effectively a questionnaire measure of empathy, predicts helping behaviour a lot more than selfish motives do. So a selfish motive would be personal distress. It's like, oh, I'm alleviating my own fear, my own kind of anxiety about this, or guilt, or shame, or sadness. So when you actually pitch, selfless against selfish acts, people say that they're motivated at least out of this kind of more well-being motive, kind of a pure kind of empathy. It's like, oh, I kind of care about your state, rather than it's like, oh, it's alleviating my own sense of guilt, whatever. But obviously there's some problems with this in the hypothetical scenarios, and you're getting people to say how they would behave in them and to try and reason about how they're making their judgments, in these situations, which again, people may or may not be able to do accurately. Aside from that, again, one of the kind of issues with this sort of model is that it assumes that there is this kind of clear distinction between self and other, between selfless and selfish. But actually, one of the kind of main findings from the social neuroscience of empathy is that this distinction between self and other is rather blurred, that there are shared representations in the brain that support both your own kind of feelings and other people's feelings. And once you've got these shared representations, you can't say who they belong to necessarily in terms of self or other. So it kind of presupposes that there is a way of easily separating out these motives that actually isn't very much supported in the contemporary literature. The idea is that there is a common basis between your own feelings and other people's feelings, and this kind of blurs the boundaries in a way that wasn't kind of anticipated when this research was done. But also other measures here. So this is not a neuroscience study. This is again a kind of more questionnaire-based study. But what they did here is this measure called including others in the self. So how much would you kind of have a notion of other people within your self-concept and having that person within your self-concept? And what they find is that this is the biggest predictor over and above kind of selfless acts, is how much you feel that that other person is kind of part of your own identity or concept. It sounds very abstract, but actually that's what it is. So again, as soon as you do that, it's impossible to say what's selfish or what's selfless, in effect, because you're treating other people as kind of being, part of you, in effect, in a psychological sense. But that's something we'll come back to in other lectures, and it is supported again by neuroscience, the idea that people do have the sense of, the self not just being themselves, but incorporating certain others who they like or who are like them within this. So in terms of more neuroscience mechanisms of altruism, this is an fMRI study by Moll et al. About charitable giving. And basically what they have here is they're presented with various kind of mission statements. So here's one called Death with Dignity, showing allowing euthanasia for the terminally ill. And what you can effectively do here is that you can decide whether or not you are going to give money to that charity or not, and it gives you a decision. So here, for instance, the decision is that if you choose yes, if you choose to donate, you'll get nothing, but the organisation will get $5 here. For instance, if you choose not to donate, that you'll get that, okay, and the organisation will get this. But if you choose not to donate, then basically you don't get anything, and the organisation doesn't get the $5 that they would otherwise have. That's kind of what it's saying here. So in this case, it's not costing you anything to give, but they set it up that in other cases it costs you something to give. So in these situations here, it's costly, so it costs you $2 in order to give $5, okay? You could debate whether these are realistic or whatever. I mean, the government kind of has this charity giving sort of bonus, doesn't it? But the idea is that the charity can make more out of $2 because they can invest it, or they can accumulate other $2 in which to kind of grow a pot, in effect, in a way that you can't with $2 in your pound by pooling the money. That's kind of the basis here. So in some cases it costs you to give, and others it doesn't. So that's basically all it's showing here in this matrix, is that you've got two things. One is something that costs you, one is that doesn't cost you, and one where you choose to give, and one where you don't choose to give. So you've kind of got four conditions in the experiment. And then what you've got here is a fifth condition, which is called a pure reward condition. And basically it has nothing to do with the charity. Just on some trials, a message appears on the screen saying, you've got $2, an organisation gets nothing or whatever. So it's just like, bingo, here's some money for you. Okay? So that's the basic design here. So basically what you find here is that when you make a decision to give to charity, you activate your striatum, your ventral dorsal striatum. So this contains the nucleus accumbens. It's kind of one of your classic reward centers in the brain. And you also get the same activity when you get a pure reward, and you even get it when it's costly to yourself. So it doesn't matter whether or not you're giving away $5 and it's not costing you anything, or you're giving away $5 it's costing you $2. If you're giving to something that you like, then you get activity in this reward center in the same way as you get something from receiving it. So again, this suggests that that basically you've got, the way that they've described this is in terms of a joy of giving effect, that basically that it is rewarding to give money away, okay? And it's not just some kind of economic mistake that somebody's made, that actually there is some psychological benefits to it, and that's why people do it. So that's what happens when people choose to donate. When people decide not to donate, you activate part of your prefrontal cortex. So this is the ventromedial prefrontal cortex. This is part of your kind of more orbital surface that's involved in kind of contextualizing emotions and so on. So again, in this lateral region of the orbitofrontal cortex. So this is also the part of the brain, if we think back to that chocolate eating study, when you've eaten enough chocolate and you can't have another mouthful, this is the kind of the part of the region that you get. Whereas when you want chocolate, you get a different region of the orbitofrontal cortex. So this is the, you've got the same kind of region activated when you're deciding, I'm not going to give money to that charity, okay? So again, you've got these kinds of different regions within the reward network that are deciding when you're going to give and when you're not going to give here. Okay, so game theory is basically, it's a branch of maths that kind of captures how an individual's success in making decisions is influenced by the decision of others. So we've kind of, a lot of the examples I've given so far are examples from game theory, even though I haven't kind of phrased it like that. So in economics, it's often used to find an optimal decision for an individual, so the one that kind of maximizes their benefits for the least cost, but that takes into account a social element, how other people should or will make their decisions, in effect. So basically in biology, game theory has been used to kind of model evolution based on the concept of fitness. So the Axelrod and Hamilton kind of model I talked about, this is kind of game theory in effect, where you're trying to figure out what the optimal decision is to cooperate or not cooperate, given how other people treat you or the kind of decisions they make. That would kind of be it here. So I put JMS here because this is John Maynard Smith. So there's a building named after him here. So he was the person who first applied game theory into biology, in effect, and kind of started this particular trend. So this has kind of a long tradition of Sussex. The person who came up with game theory is in the Russell Crowe film. The guy who became schizophrenic is called John Nash. He was it Princeton or Harvard? It was kind of 1950s, around this period, I think, was when it was. But anyway, he was the person who came up with game theory. And it's kind of been interesting in terms of kind of politics as well, in terms of kind of nuclear war scenario. So it's called mutually assured destruction. The optimal solution is if your opponent has nuclear weapons, that you should have nuclear weapons too, but neither of you should ever use them. So it's kind of used in this kind of Cold War rhetoric as well as being kind of a game theoretic kind of solution. It's that if your opponent has nuclear weapons, you also need them, but you should never use them, is basically the bottom line, because that would be disadvantageous to both of you. But that's kind of an example of game theory, in effect. So in psychology, we kind of apply it to real-life social decision-making. That basically people don't necessarily make the optimal economic judgment. And here we can really think about this in terms of the brain's mechanisms to do with rewards and value, in that basically economic rewards and social rewards tap the same things. So when we sometimes seem to make a decision that is economically disadvantageous, it doesn't mean that we're doing something mad. It just means that we're kind of valuing something socially more than we are economically. And that is not an illogical or a bad thing, given that we're a social species. But this is a slightly different way of framing it than you would get in kind of the economic application of game theory. But we'll see about this. And this has kind of led to this thing called neuroeconomics, which we'll talk about. A lot of what the second part is neuroeconomics, in effect. So human interactions basically all evolve around mechanisms for exchange, trust, fairness, so how we kind of do this. And this is effectively what's mirrored as you kind of go up to institutional levels, such as, banks and so on, that they're all based on these kinds of notions of trust and fairness, that, you can pull all your money out of a bank and it will kind of collapse and so on, but this doesn't happen because you've kind of got trust and faith and so on in it. So it's these basic kind of psychological mechanisms that kind of create this kind of complex socioeconomic world, in effect, would be the way of thinking about this. So what I'll go through is various kind of games and dilemmas that have been used that they still relate very much to cooperation and competition, but are kind of framed in this particular way. How many people have come across the prisoner's dilemma before? Okay. Right, let me go through this. I find this quite not straightforward thing to get, but when I explain it in terms of money, I find it a bit easier. But anyway, this is the story. So two suspects are arrested by the police. Here they are, A and B. The police have insufficient evidence for a conviction, and having separated both prisoners, visit each of them to offer the same deal. If one testifies for the prosecution against the other, and the other remains silent, the betrayer goes free, and the silent accomplice receives a full 10 sentence. So basically, if one dobs the other one in, then the person who's been dobbed in gets 10 years, and you get to go out. Okay. If both remain silent, so if you don't dob each other in, you both get 6 months in prison. They just kind of put you in prison for trespassing or some minor charge, okay, whatever it is. But if you each betray each other, so if you say he did it and he says you did it, then you both get 5 years in jail. Okay. And the idea is that these are completely independent decisions, so you can't find out what the other person decides and then makes your decision. And the question here is, how should the prisoners act? What should you do? Should you choose to betray the other person and say he did it, or should you choose to cooperate? Okay. I'll give you a minute or so to kind of discuss it with a pair, what the optimal decision is. Or maybe you just look at the next slide. But anyway, try and figure it out. Okay, let me kind of give you the options. So this is, it's kind of a different way of framing it, but it becomes very obvious when you frame it this way, is that basically if you choose to betray the other person, so you say they did it, you will either get 5 years or 0 years, depending on how they make their decision. Whereas if you choose to remain silent, you will either get 10 years or 6 months, depending on what their decision is. So the question is, which one are you going to choose? It's quite obvious that you're going to choose to betray the other person, because here you've got a choice between 0 and 5 years, depending on what they decide, whereas if you remain silent, you've got a choice between 6 and 10. Okay? But people find it very hard to kind of get to this solution, and it's partly around, obviously, the wording of it, but it's not just about that. And one of the problems here is that collectively the best decision is for both people to remain silent. In effect, so if you both remain silent, then the sum of the prison sentences is 1 year. If here the sum of the prison says 10 years in each of these ones. So actually the lightest sentence overall for you and the other person is if both of you remain silent. But by remaining silent, you're not going to get 0 years. It becomes impossible. You either get the 10 or the 6. Okay. So one of the dilemmas is kind of around this, and it's almost around the fact that you kind of struggle to it's very hard to think independently and dissociate yourself from the other person's decisions, or not to kind of think about the collective outcomes. Did many people struggle to kind of get to this sort of answer? Yeah, it's not straightforward, is it? The way that this kind of works in real world situations is more in terms of money, where what you do is instead of having prison sentences, you have monetary rewards, and obviously you flip it round, so a good thing is plus money and a bad thing is you get nothing or you lose something. And by doing it with money, you can play various rounds with people as well. So basically what you would have is that instead of having prison sentences, you've got something like this. So what this means is you play against 2 players. If you both decide to cooperate with each other, you'll get $2 each. So imagine that I'm player B. If I decide to cooperate and you decide to defect, you get $3, okay? And I get nothing. If I decide to defect and you cooperate, then I get 3 and you get nothing. And if you do nothing, you get 1. If both of you effectively say, I'm not going to cooperate, you get $1 each. So again, the interesting thing here is that in kind of just one trial, the best thing you can do is effectively to dob the other person in and try to get $3 for yourself and just say, I'm not going to cooperate. As you play the game over time, what you want to do is that you want to carry on cooperating. Because if you imagine playing this game with somebody kind of across multiple trials, they will change their behaviour. So basically, if we both agree to cooperate, we will have $2 each. But if on the next trial I say, no, I'm not cooperating, and he cooperates, I'll get 3 and he'll get 0. Now the question is, what should he then do next? Okay, and this becomes like the evolutionary game before, is that his optimal strategy then is to not cooperate with me, because otherwise if he keeps on cooperating, I will kind of dob him in and get the higher reward. Okay, so there has to be this kind of retaliation coming in. So again, what this is effectively like the evolutionary kind of arms race described before, and it's just played out with 2 players with money. So ideally, cooperation tends to kind of be better than defection because you both get this kind of reward. This is risky, so the rewards are higher here because you can get $3, but the danger is that they will return on the next one and they'll say defect, in effect. They'll say, I'm not cooperating. And if you both end up not cooperating, you'll end up getting $1. So I'll say, I'm not cooperating, $1 each. I'm not cooperating. And as soon as somebody cooperates and somebody says, I'm not cooperating, then you get 0 and they get 3, and you'll be so pissed off, basically. So there's kind of a mutual incentive to cooperate, but then you've got this kind of temptation of choosing the other option, in effect. So this is how people play the game. So this is over 20 rounds here. And this is an fMRI study, but so here, this is when you're playing against a human partner. And what you find here is that this is CC, so this is where both players choose to cooperate. This is against where the person's told they're playing against a computer. In both cases, they're playing against a computer, and the computer's just doing tit for tat. But in one case, the person thinks they're playing against a human. So when people think they're playing against a human, the levels of mutual cooperation are much higher than when they think they're playing against a computer. So when you play against a computer, you go for these cells here and try to get the big reward off the computer, whereas you're less likely to do that when you think you're playing against a human. And again, people report certain kind of emotions when they're playing this game, depending on what their kind of decisions and their behavior is. So when both players are kind of choosing to cooperate in order to get the higher kind of mutual reward, they report a feeling of camaraderie and trust. You know, oh, we're in this together, we're both getting this $2 reward. When one person chooses to kind of betray, then the person who's betrayed obviously feels anger, but the person who did that can feel guilt as well. So this is a disincentive for doing it. But particularly when you're against another human, because you're not going to feel guilty about cheating a computer out of money necessarily. So there is this kind of emotion aspect to it. And then here, this is hatred. Basically, so you're both saying no, 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 and you're getting $1 when you could be getting 2 or 3. But by going no, 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 you're stopping the other person from exploiting you. So saying no all the time will stop the exploitation, but it will give you a low reward. Okay. So this is how people behave. They're more likely to cooperate. But what you find is that even when you compare these trials here against those there, so if you compare trials in which you've mutually cooperated with another human as opposed to mutually cooperated with a computer, you find greater reward in your nucleus accumbens and orbitofrontal cortex for those trials relative to the other, even though the monetary rewards are the same. So in both cases, you both decided to cooperate. But it's almost as if there's something intrinsically rewarding about cooperating with another human. Okay? That's effectively what this is saying. So it also suggests that the reasons why we cooperate isn't just for Machiavellian reasons or whatever. It's that there is something rewarding about working together to achieve an outcome. That's kind of, in this kind of complex, neuroeconomic thing, that's the take-home message that comes out of it. So mutual cooperation with the computer wasn't associated with this kind of striatal activity at all, even though the monetary rewards are the same. So that's curious. The other interesting thing is that you might expect that you're going to get most reward-related activity in this condition when you're getting the highest monetary reward of $3, but you don't. So in that case, when you cooperate and the other person doesn't, where you've got this high reward, you actually get a lot of activity in your amygdala and your insula, which are kind of correlate with self-reports of anger, irritation, disappointment. Oh, hang on, no, it's the other way around. It's where you've got 0 and the other person's got 3, okay, in this case. But basically, your nucleus accumbens isn't as active when you're winning $3 than when you're getting $2 via cooperation. Okay, so again, you've got this trade-off that somehow cooperating is worth more than $1, at least in terms of neural activity. Okay, so that's the prisoner's dilemma. The ultimatum game is a much simpler paradigm. And basically, this is another 2-player game where you've got 2 decisions to be made. So you're given $20, and your decision is how much are you going to share with the other player. And you could share between $20 or I think the minimum is $1. Okay? So in this case, you decide to give the other player $10. What then happens is that the other player decides whether to accept your offer. If they accept the offer, you get $10 each. Or you reject the offer, in which case you get nothing. Okay? The idea behind this is that this is just what's called a one-shot game, that you just play it once with a person so there's no chance of retaliation. And the question here is, what is the optimal decision for the proposer and the responder to make? Okay? If you're only playing this game once, the optimal decision of the proposer is to give you the minimum amount of $1, for instance, and the optimal decision of the responder is to accept whatever money they're given, because at the end of the day, any money is better than zero. So to reject an offer is completely economically stupid, according to game theory, okay? What you find when people play this game, even with oneshot, is that people routinely reject low offers. So with offers lower than 20%, so in this case, if they're given $4 or less, people will reject them. Now, from an economic perspective, this is ridiculous, because in what sense is $0 better than 4? It's almost as if the person can't kind of do a basic calculation. They've done similar things with chimpanzees who seem to do better on this game and kind of understand that something is always better than nothing. So they kind of show better knowledge of game theory than humans do in this. So the question is, why are people rejecting the offer here? Is it that they're just mistaken and they can't kind of weigh them up, or is something else going on? What kind of ideas? Yeah, punishment is the standard example here. So the idea is that they're punishing the other person in effect. So that's the normal explanation. So in a way, the way that you would think about this is that this person here is weighing up two values, and it's not just the value between $4 and $0. It's the value of money versus the value of fairness. Okay, and often they value fairness more than they value this pittance that you're giving me, in effect. That's effectively what they're saying. So, and it's kind of tapping into the basic idea that the reward system for social value and social rewards is not completely different from the value of monetary rewards, that the nucleus accumbens has a kind of a common currency of kind of dopamine activity and so on, and it doesn't completely distinguish between the two, and it can make a decision between them. But that is the explanation. Yeah. So according to game theory, you should give the least amount and accept whatever's given, but people don't do that. So if you do this with fMRI and you compare fair versus unfair offers, again, what you find here is that they set it up so that in some situations you think you're playing against a human, in another situation you think you're playing against a computer. You're always playing against a computer as it happens. But you're more likely to accept unfair offers from a computer. And again, this is consistent with the idea that it's something about punishment rather than a lack of numerical skills or something odd like this that's going on here, is that there's no point in punishing a computer because they don't have the same kind of mental states and emotions that we do.
Just an idea, have they been these kind of studies where they thought that the person was a child?
I bet there is, yeah. There's kind of, it's one of these things that's been replicated a lot, but I wouldn't be so sure. I couldn't think of one, but yes. It's obviously done kind of within groups, out groups, and things like this as well. And you would get differences there, and personality traits as well. So when I talk about the psychopathy one, that they don't feel the guilt here, and they will kind of show different ones. So yeah, there's lots of kind of different variables. Yeah, it's a good question. Yeah. What you find is that when you compare kind of offers from humans versus computer, again, when you've got an unfair offer, you activate the insula, the anterior cingulate, and so on. So these are parts of the emotional brain, but they're not really parts of the reward circuitry. You wouldn't think of them as kind of computing reward in the same way as you might the nucleus accumbens, the orbitofrontal cortex. It's more about danger, disgust, this kind of thing is traditionally how we would kind of label those sorts of regions. This is your prefrontal cortex, which I'll go to. So the activity of the insula to an unfair offer, particularly when the unfair offer has come from a human, is interpreted as kind of an emotional reaction of disgust. And basically, the insular activity is much greater when you reject an unfair offer than when you accept it. So even if you're given $4 and reject it versus $4 and accept it, your insula will be greater, more active in the instance in which you've rejected it. So it's almost as if it's guiding that. It's like, I'm not having this, and it's kind of guiding your decision. And the idea is that the frontal cortex is kind of something that's keeping the emotional brain and your kind of rational economic brain kind of in check as kind of a biasing influence on them. But the question is, which way is it biasing you? Is it biasing you towards or away fairness? One way of looking at this is to use TMS. So TMS is a kind of temporary disruption of the frontal lobe. So you apply this kind of big magnetic coil over it and see how people's behavior changes in the ultimatum game. And what you find here, so this is, they do it on the left side, the right side, and sham, and this is the amount of acceptance rate of unfair offers. So basically, when you apply TMS over the over your right frontal lobes, you're more willing to accept unfair offers, in effect. So it's kind of making you more rational and less emotional, basically, in terms of your decision making by applying TMS and disrupting over the frontal lobes. Interestingly, it's changing your behavior, but it's not changing your subjective evaluation of fairness. So in this case, it's just, am I going to accept that money or not? Here, is that offer fair or not? And actually what you find is that people still rate the offer as unfair. It's not all of a sudden that they see $4 as being, oh yeah, that sounds reasonable. They still recognize it as an unfair offer, but they're going to accept it anyway. So it's kind of flipping the brain from responding on the basis of, as opposed to like, well, $4 better than nothing, isn't it? It's that kind of bias. So again, you've got this kind of control of emotion kind of affecting social decision making here. Okay. This is cross-cultural perspectives on the ultimatum game. So Henrik et al. Has done kind of a series of these economic games across cultures. And again, they enter all kinds of different variables in there. And basically what you find is that the larger the community that you live in, the kind of more stringent you are in terms of your rules of fairness, in effect. So the minimum acceptable offers there, or your kind of willingness to punish in the ultimatum game. So basically, the larger community you have, the more you kind of want to be given to you. So you're kind of, if you come from a large-scale community, you expect this value here to be higher, okay? And you will kind of punish lower. What's going on here? So it doesn't seem to be to do with other things such as collectivism or kind of wealth. So they kind of look at other things such as one of the other things is whether you're self-sustained. So it's how much of your own food, how much of the food you eat have you grown yourself, which tends to be zero, obviously, in Western societies and would vary in other kinds of societies. And basically, the more, this is also something that seems to matter. So those who come from large communities and those who trade seem to enforce a high level of fairness. They want something much closer to a 50-50 split, basically, to be fair. Whereas those who come from smaller communities tend not to. And it's not all about kind of Western versus Eastern and so on. It seems to be whether or not you are kind of trading and whether or not you kind of got large communities. So it's almost as if this kind of transition into larger communities has kind of led to more rigid norms of enforcing punishment against these sorts of fairness violations, but that's happened kind of independently across different cultures. That's the claim from this study here. You can kind of unpick it. It's quite a hefty paper to read, actually. Okay. So the public goods game is seen as being kind of related again to tax. It involves many players, so here it involves 4 people. And basically what you do is that you choose how much money you're going to invest in a pot. Obviously, that isn't quite like taxation, but the idea is you can choose whether to work or not to some extent, and you can choose how hard you work, and you can choose kind of what job. That's the kind of analogy here. So let's have a look. So all 4 players have been given $20 to begin with. They can decide how much to give to the pot. These 3 players have decided to donate £10, or that they've worked 10 units or whatever, and it's gone into the tax system here. This person has decided to freeload. They're not donating. So what's happened here is that you've got $30 in the pot, and then you can it goes through some kind of multiplier. So here we've effectively doubled it. So you could think of this in terms of investment, or you can think of this in terms of kind of collective gain, that basically in order to have kind of a modern welfare state, you can't just buy it yourself individually. You kind of get en masse by investing kind of $1 million in research or in, an MRI scanner or whatever to do this. So it's something you can't achieve yourself, but by pooling resources, you get something bigger out of it. That's the idea behind the multiplier here. And then this is the key thing that is supposed to make it more equivalent to taxation, or what they call public goods. And that is that basically everybody draws from the pot in the same way. And the analogy here is that no matter how much tax you paid, you are still entitled to the same level of healthcare, education, national security, whatever, paying for soldiers, whatever the taxation spent on. So it doesn't matter what you contribute, you pull out the same from the pot. So that is the analogy that makes it kind of equivalent to tax. So what that means here is that when you add up the money that's come back from this, is that the people who decided to pay the tax have benefited from the public goods. So it's gone up in monetary terms from $20 to $25. But the person who opted to stay at home and watch Jeremy Kyle now has $35 in their pot. So the paradox here is that the best individual decision to make from an economic perspective is to do nothing and hope that everybody else pays their tax, and to enjoy the benefits that can accrue from this kind of collective means kind of flowing back to you. Okay, that is the best decision you can make economically. Now, obviously, this is kind of problematic, because there would be no money in the pot if everybody assumed that basic position. So, how does this work? What you find is that when you play this game within the normal population, you would find free riding in about 30% of the population. So about 30% of people naturally kind of do that when they play this game. What it means in real life is less clear for these people. Others kind of what they do is that they, or the ones in green here, they're called kind of conditional cooperators. And what that means is that as other people kind of contribute more, they follow suit. So you kind of have this kind of almost collective agreement that, over time everybody gives a little bit more, and then that they would effectively follow suit. And then you have people who have a mixed strategy, who kind of continue to pay into the pot, and eventually they decide they're going to reduce their amount, kind of sit back and let the money flow back to them, this kind of hump-shaped ones here. So you kind of have mixed strategies in here. And this is also, they link this to kind of various genetic differences with regards to dopamine or whatever. I'd have to look it up, but I came across some studies recently. So what to do about free riding here? How can you get rid of this from this sort of game? Actually, what you can, the way that it drops out is if these players here can spend money in order to punish that person, then it drops out. So the way that you do it is that you could spend $1 in order to reduce their pot by $2. Okay, so a $1 fine from each of these people would have a $6 kind of negative difference on them, should they choose to do that. As soon as you introduce that into the game, people stop freeloading and they start to cooperate, basically, with this. So the sanctions do kind of work, at least in this sort of economic game. Interestingly, it's not all about punishment. So rewards can also get freeloaders to change their behavior. So what you can also do is that if this person has been kind of really generous or whatever, you can choose, the other players can choose to say, spend $1 in order to increase their pot by $2. So in this case, that nobody would ever give money to the freeloader, but they might kind of say, oh, you've been a bit generous, let me give you an extra $1 or something. People do that. But what happens is that the freeloader then reverts their behavior and starts to contribute more just by seeing other people being rewarded via these kind of individual donations, basically, into each other's pot. So punishment works, but actually modeling other kinds of behavior also works in terms of stopping freeloading in this game. So the trust game is the last one that I will go through. So the trust game resembles the public goods game in the sense that there's an investment that is in effect doubled or tripled and then is kind of fed back to the other players. But it's a two-player game. So you've got one person who's given some money and they decide how much to invest. So this person's decided to invest $10. As with the public goods game, the investment gets tripled. Okay. Then what happens is that the money is effectively shared, but the trustee decides how much to kind of share back, in effect. So this person's decided on a 50-50 split. So this person's gained $5 out of their investment, and the bank's taken $15 in effect out of this. Then the person here would decide how much to invest again. So it's called the trust game because basically the idea here is that what you're wanting to do is that you're kind of learning about each other's behavior. So in this case, the person's returned something that would generally be perceived as a fair return. So this person here would then feel like, oh yeah, I'm going to donate another 10 or another 12 here because I know I'll get something back. But of course the trustee at any point can say, no, the bank's closed, I'm taking the money now. So there is this kind of, you're laying yourself potentially open to exploitation here because the trustee on each trial can just suddenly decide, no, this money's mine, I'm giving you $0 back. Now obviously there is a consequence for that because then the investor won't invest again, and the trustee's ability to kind of make money is diminished. Okay, so the idea here is that this is obviously how real world kind of investment works, but it involves notions of trust and the exploitation, risk of exploitation, but the fact that the bank can suddenly take all your money for sure, but then that closes that door because people are not going to go back again. Okay, so the idea is that you've kind of got these sorts of mechanisms that deal with it, one-to-one exchanges, but that kind of permeates to kind of our social institutions with banks and investments and so on. But they're all predicated on the fact that our minds can work this way. Okay, so what happens here when you play the trust game? So this is a study that I kind of alluded to briefly, in which you've got what's called hyperscanning fMRI, in which you've got two scanners kind of side by side, so people are literally playing against each other rather than think they're playing against a human or there is a human in the other room. You're actually scanning each other's brains here. And what you find here is that, without going into too much detail, is that the signal in one person's brain correlates with the signal in the other. So as one person makes a decision, yeah, I'm going to decide to give you some money, the other person's brain responds. And you do get activity in the striatum. So again, these are your reward-related regions. So what they do in this study is that they divide trials into fair trials. So that's in which you get kind of like for like. So you invest some money and you get a reasonable amount back. Malevolent trials in which your trust is betrayed. So they say, haha, I'm keeping the money myself this time. Or benevolent. So that means that they're being generous. So you're getting unexpected rewards. Okay. So what you've kind of got here is time course, and this is your activity in the nucleus, well, in your striatum, in the reward-related regions. And what you find here is that here somebody's submitted their responses. What you see on the screen is that the person's made a decision. Okay. What you see here is that you get to see what the decision is, how much money they've given you. And the difference here is when is how much kind of activity you've got in your reward mechanism relative to baseline. So here, this is when you've got, an unexpected reward or whatever, that you see this kind of reward-related activity here. The interesting thing about this is that this here is at the start of the game, this is in the middle of the game, and this is in the end of the game here. And what you can see is that there's a shift in this kind of activity from occurring when you get the reward to occurring when the person's made their decision and before you get the reward. So if you remember that this is a region that seems to encode kind of expectations of reward. If you remember before I showed you something where you've got, say, a flash of light that predicts some food, and initially you get activity when you get the food, but eventually you get activity when you see the flash of light and you get nothing when you get the food, because it's like, it's almost if the reward is transferred onto the queue rather than the thing itself. But this is what you're kind of seeing here, is a transfer here from activity when you've actually got the reward to activity before you've got the reward. Just being told the person's made their decision is rewarding in its own right. Okay? So here you've got this kind of bimodal peak, both when you get the reward and when you're told the person's made the decision. And eventually you get it far more just when the person's made their decision. So again, here it suggests that the reward almost transfers from the monetary reward to the actual interpersonal reaction interaction as a result of playing this game with somebody and building up trust. Okay. And this is a neat kind of version of the trust game in which they introduce reputation. So we've come across reputation a few times in terms of, altruism and so on. Here, all you do is that you're playing the trust game with 3 different players. But before you play them, you read something about their life story. In one case, they're kind of, a pillar of the community, do a bit of charity work, they help out, kind of family man and so on. Negative would be kind of, swindles a little bit, cheats on their wife, I don't know, this kind of shady character. Neutral would be, something in between or whatever. What's interesting about this is that when you're actually doing the game in the scanner, all 3 players are playing equally. Again, it's set up by the computer. That your the amount of return on the investments all preset by some algorithm here. So it provides equal returns in them. So there is no economic difference between the 3 players. It's all in the reputation, okay, of them. And what you find here is that actually for those with neutral representations, it's where you get all the reward-based learning or finding out about this. So it's almost as if there's a saying that your reputation kind of comes before you, and basically it does in the sense of that you don't seem to show the same kind of learning pattern. If you know somebody or think something about their behaviour, you don't show the same responsiveness when they're behaving kind of badly or not badly. Whereas when it's neutral, it's almost as if you're trying to figure out whether this person can be trusted or not, and you show much kind of variability in the signal in terms of how you're kind of learning in terms of the different amounts fed back to you. Whereas in the others, it's almost as if it's completely blunted, this kind of learning mechanism with this. So again, it's one of those studies that's a very nice kind of example between what I would think of as being a very high-level mechanism, gossip, reputation, kind of your belief about people in the world, versus something very basic, a kind of neural mechanism that's conserved from mice through to, to humans. It's doing pretty much the same thing in mice as it is in humans, but humans can kind of work in different kind of contexts to do this. Okay. Any questions about these games? Okay. It's a difficult literature, but it's interesting, and it really does open up kind of big questions about tax and banks and these kinds of things, and that's why it's kind of appealed to economists and psychologists and so on as well. That it's got this kind of very interdisciplinary feel to it in terms of the sort of implications that it has. So to summarize, why do we cooperate? I think that there's a whole number of reasons why we do it. I think one is that basically there's an intrinsic desire to help. So again, there's good evidence that social interactions, or at least positive ones, are rewarding in their own right. There's something rewarding about working together to get a reward, even when you can just get the same level of reward not via cooperation. Cooperation has some added value psychologically, but you can see it within the neural mechanisms as well. There is some material benefits as well, so it's not all about kindness and so on. There is benefits of reciprocity, so the idea that if you help somebody else, help will return to you, and also it benefits your reputation. So there are material benefits here as well from helping others. I think people also cooperate because we kind of devise certain sanctions for non-cooperation. So those who don't play the game or whatever, they can be punished either materially or physically or whatever, and we can think of lots of examples for that. I don't think that explains why people cooperate. I think it explains, why, it kind of keeps people on track and avoids things falling apart too much at the edges, in effect. But also, one's reputation and social standing will fall by not cooperating. If you think you're not pulling your weight or whatever, or freeloading, this is stigmatizing as well as anything else. Another one is obviously kind of a desire to conform. I think that, this is important. It's obviously not the main motivation, but it kind of, as with 3 and 4, it kind of keeps people along a steady path. I think that the main mechanisms are around 1 and 2 here. Okay, so in the next lecture, we'll look at relationships. So it's all about love.